to see whether or not it has written the uptime file. And indeed it has. So it ran it at that minute, 15:10. Let's cat the contents of linuxcbt uptime.stat. And there we see the uptime. So every minute, that little job will continue to append to the uptime.stat file, giving us data that we could possibly parse using some other process, perhaps ultimately uploading it to a spreadsheet or otherwise. Now that's a job that's going to run every 1 minute. Now the same job could be specified on a per user basis using the cron tab utility. So this runs every 1 minute. And by now it's possibly run again. Let's do a date to see if it's 15:11. And it's a few seconds off. That means if we now cat the contents, by now we should see 2 entries. Now we see the 2 entries, so it just hit. So there's a second entry, and the utilization is roughly the same, slightly off in the 1 minute mark and the 15-minute mark. So let's take a look at our notes. Define per user job. So the same job to be defined on a per user basis means we'll invoke cron tab with the E option to edit the cron tab or table for the user Linux CBT. Now you can do this as a user root or as the user Linux CBT. So let's do it both ways. Cron tab E is the user, so let's just note run as user principal, which means the user Linux CBT, will propel us into the default editor, giving us the ability to specify the job, and we'll do it sans the username because it isn't required. So let's find a shell where we're the user Linux CBT, and momentarily we'll be able to run cron tab. And perhaps we'll set a different stepping. So cron tab E. And by the way, let's just do a which so that you see where cron tab is located. User bin. It's accessible to everyone. So long as you're not listed in cron.deny or you are actually omitted or you're not omitted from cron.allow, you'll be able to submit jobs to the scheduler. So cron tab E. Now this propels us into the default editor VI. If VI is not your thing, then export the editor variable, setting it equal to an editor that's in your path, such as nano. Then rerun cron tab E. Now it propels us into nano. So we'll paste the entry and remove the username because it's unrequired when specifying the job as a user. So this will run every minute. Now supposing we wanted to differentiate the file so that we know that it's running. So uptime.linuxcbt.stat to differentiate. And this will also run every 1 minute. Now let's confirm in 50 seconds or so, cron will wake up and realize that there's been a change to the var spool cron tabs directory, and we'll process the contents. Now if we look at the directory now, you'll see that only uptime.stat with tab completion exists. And as mentioned, user entries are stored. So let's take a look at var spool cron in var spool cron. So what you'll see here now is an entry for Linux CBT, which only Linux CBT and root may interact with. And if we cat the contents, in fact, let's file the contents first. It's just a text file, and if we cat the contents, you'll see it's the job verbatim as we entered it as the user Linux CBT. Now let's compare the time. We should have in about 10 seconds cron D waking up and creating the job. And as a user Linux CBT, let's lsltr, we should see momentarily uptime.linuxcbt.stat. Let's specifically look at upstar. And indeed, there's the new file, 71 bytes. Let's cat uptime.linuxcbt.stat. And indeed, the entry has been created. Let's see if it reflects uptime.stat, which ran at the same time as well. So let's cat that, and let's see what the load average was for 15:14:03. And notice 32:25:12, the settings are identical. But of course, the one that's been running longer contains more data. It's nicely formatted. It can be parsed using, let's say, awk. We've already looked at awk, so you can parse this out with awk. For example, supposing you want to parse this, you'd simply awk, and the field separator is comma, and you'd want to, let's say, print. So let's go ahead and indicate our single colon, and that's going to be curly brace. Print me, let's say, field number 1 from, and we actually inadvertently didn't get the single quote there, from our uptime file from Linux CBT, and there is the first column, and of course we can then print additional columns. Let's cat the file again just to see what may be of interest. And that's uptime.stat, but perhaps uptime.linuxcbt.stat contains two. So supposing we wanted the timestamp as well as the number of users connected to various TTYs, and maybe the load average for 1 minute, just to give us a sense. So what we could do, we now know that we need to get, in addition to column 1, we want column 2 and column 3 to pull that information. So that's almost everything. So that brings us out, and actually there should be a comma. Let's see, 3 users, and we've got 1, 2, so that's the second. We don't want that one, so let's take this off. We actually want 1, 3, and 4. And this will bring us the fields that we're interested in. Let's take a look. We didn't include the number of the column, and there's 4. So now we've got 1, 3, and 4, which can be further parsed if there is a new delimiter. Now the common denominator delimiter here is space, so we could, for example, rerun awk, and since space is the default, take the default with curly brace and instruct it to print, let's say, the time that the process was run, which is column 1, perhaps the number of users, which will be in this case the 5th, or this will be the 5th column. So let's go with 5 and maybe even 6, so that we know it pertains to users. And maybe let's go with the 8th column. And this should give us a sense of just those fields. So users, average, and let's see how this has pulled it out. So it pulled the first as this, the 5th as 3, the 6th as users, so 3 users. This is the 7th, and it took the 8th as average, so let's get the 9th as well. And that's how you'd pull those fields out. And you could further parse if you'd like, using space, and then eventually using colon if you saw fit. So you could continue to pipe into awk over and over again to get the fields out that are of interest to you. Now while we're doing that, the file continues to build. Notice every passing minute it writes. So 14, 15, 16, 17, and it's about to write to the 18th minute. And you can compare and contrast the load averages for 1 minute, or parse out 5 or 15, and so on. So now we have jobs running in 2 contexts, from the system-wide context and the user-wide context. Now, root may manipulate any user's job. So let's go ahead and manipulate Linux CBT's job as root using cron tab E. So this here should be labeled as A since it's the first in the list. So we'll run cron tab E followed by the username Linux CBT as root. So run as root. This allows root to manipulate any user's job. So we'll find our root shell. Again, that just manipulates the entry in varspool cron. If we take a look, let's stat it. We should see that it was last updated 15:13 and 3 seconds and a number of nanoseconds. So let's cron tab E. You could also manipulate the file directly using the editor, but cron tab is just a shortcut which invokes your editor. So cron tab, and this, in fact, we want the user. So this is the user Linux CBT, not the principal. And let's go ahead. That is actually E for the user. So we're going to edit the user's cron file. So let's go ahead. Linux CBT. And our editor is off, although we could modify it with it. But let's go ahead and export editor equals nano semicolon, or to be sure that it was done, ampersand, ampersand, then cron tab E. So now, here's the job, and this is the user's entry. So supposing we wanted this to be updated every 2 minutes, then instead, it'll update every 2 minutes. And if we restat the contents of the file, you'll see that it's been recently updated. And we can also use cron tab to list a particular user's cron tab entry using, of course, we keep omitting the user option, and that's LU. So this shows you the jobs that are defined. You can also define multiple jobs. Let's just update our notes. That's going to be cron tab edit the user's jobs, or cron tab list the user's job. Run as root lists users job or jobs. And this edits users job or jobs, if you make changes, of course. But it flags the timestamp change on the file, which causes cron D to wake up and notice the difference. Now the test of that 2-minute incremental or stepping should be reflected if we take a look at the users directory. Let's take a look. It's now 15:21. So now, if we look at the uptime files, we should see that at 15:21, in the 21st minute, uptime.stat was updated, which is the system-wide cron tab entry, but uptime.linuxcbt.stat was last updated at 15:20. So that means at 15:22 it'll be updated because it's every 2 minutes. So we'll give it 40-something seconds, and that'll be updated. And we can also turn off the system-wide entry by just using nano and including a comment, since we have it running as the user anyway. So a hash mark here turns this off in the next minute, so long as we save the changes quickly before the next minute comes, so that cron D sees the changes. You can include any number of jobs here and have them run. Now we should also note that cron D will process any number of jobs that are listed in etc cron dot any directory that it is told to read. So in cron D, for example, there are 2 entries. Let's cat star. We've got this 0 hourly, which runs, and as we can see here, run parts, which processes a number of items from cron.hourly. So there's a job in cron D which references the hourly schedule, which will run jobs defined in cron.hourly. Run parts, or run-parts, is just a utility which will process sequentially all of the scripts or config files indicated in a given directory. So run parts takes a look at, for this particular 0 hourly file, which is what is indicated, it looks at cron.hourly and it runs this script, 0 anacron, every hour of every day, every month, every week, and so on. Then syststat runs and it checks disk activity every 10 minutes just to see what it's doing, generates a daily summary of process accounting, and so on. So these are system tasks that are run automatically for us by our Red Hat Enterprise system. Now let's take a look to see what's changed in this user's world with respect to files. So now we see uptime.linuxcbt.stat, which was last updated at 15:20, has now been updated at 15:22, which is what we expected to see. So this is now going to be updated on a 2-minute stepping as opposed to 1-minute stepping from 15:20 to 22 to 24, and so on. We also note that uptime.stat was last updated at 15:21 because we disabled the entry in a system-wide file, and we also saved the changes before cron D woke up at the next minute. So we're able to trap that before the change was made. So there are a number of cron directories for different schedules that are relevant: weekly, daily, hourly, etc. You can take a look at any of them. So if we LSL cron star, you'll see the entries that are in each and what happens on various schedules. Now, next we're going to talk about anacron as well as at and batch, and then we'll look at the contents as a consequence of what 0 anacron does. We'll also schedule one-off jobs and show you how that works. But just in a nutshell, cron is always running on your system. If you check config list cron D, you'll see the run levels in which it runs. When you enter single user mode, it doesn't run. But for all multi-user modes, it runs because the assumption is the system's up, it's connected to the network, it's accessible. But let's just note as a feature, however, let's just note this as a 7th feature, that it runs in all multi-user modes, which means it does not run, so it does not execute in single user, which is run level 1 mode, which means that when in single user mode, you need not worry about cron jobs that may require network access, intra and internet access in order to perform their duties. Cron will not run in that run level. So if you init 1 or init S to go into run level 1, then you'll see that the cron D daemon will have stopped and not execute. So you can define your jobs with ranges, schedules, based on steppings, you name it. Rather straightforward. Just man cron tab, check the layout of the file, and you'll see how to run jobs both globally as well as, or system-wide as well as user-wide. So next, let's take a look at some of the other things that cron will allow us to do by way of @batch and anacron.